So here's where the magic really starts. Um, in the last two lessons, we learned how to sort of switch between power series and a rational function. And now we're going to take that idea and go even further with it using derivatives and integrals. And the best way to do this is just to get into examples. So let's see what I've got prepared for us. So oftentimes the way these problems are set up is they'll give you some information. So this problem says, given that the derivative of arctan x is 1 over 1 plus x squared, find a power series for arctan x. And if the problem had just said find a power series for arctan x, at this point you would be justified in running and screaming and hiding. But we're given that the derivative of arctan is this. So the idea is, let's start by find a power series for 1 over 1 plus x squared, which should hopefully be really easy given what we talked about previously, right? If I want a power series for 1 over 1 plus x squared, that actually already looks really good. This looks like a geometric series with a first term of 1 and with a common ratio of what? And that's where you think about it for a second or pause it and come up with the answer yourself. The common ratio here should be negative x squared. If it had been positive x squared, then this symbol would have been a negative, but it's a positive, so it's negative x squared. So what that tells me is that 1 over 1 plus x squared is 1 minus x squared plus x to the fourth minus x to the sixth plus x to the eighth, and so on forever, right? So wonderful. Yay, I've got this power series. So now how does that help me to get arctangent? Well, the idea is, if we recall that the derivative of arctan x is 1 over 1 plus x squared, couldn't I take the antiderivative of both sides? When I take the antiderivative, I'm effectively going to find that the antiderivative of 1 over 1 plus x squared is arctan, is this thing that I've been looking for. So now all I have to do is take the integral of 1 over 1 plus x squared, which means take the integral of this, right? We should be able to conclude that arctan x is the integral of this thing, of 1 minus x squared plus x to the fourth minus x to the sixth dx. So I'm going to get that arctan x is x, notice I'm leaving a blank space here, I'll get there in a second, x minus x cubed over 3 plus x to the fifth over 5 minus x to the seventh over 7, and so on. So why did I leave a blank? I left a blank because we should put in a plus c there, and we should figure out what this constant is. The way that you're going to do that is by plugging in a really convenient value. And in this case, I'm going to plug in 0. Now, why is 0 convenient? 0 is convenient because this power series is clearly centered at 0. So if I plug in 0 for all of these things, all of them will disappear. So I'll use a different color for this. So I'm going to get arctan 0 equals c plus a long string of zeros. So in other words, c. The arctan of 0 is 0. So c is 0. So great, that means this c didn't matter, and this is our answer. The power series for arctan x is x minus x cubed over 3 plus x to the fifth over 5 minus x to the seventh over 7, and so on. The way that we find the interval of convergence for this is to just find the interval of convergence for the thing that we started with, right? So because this thing up here was geometric, it was geometric with a common ratio of negative x squared, we just need to look at when, so for the interval of convergence, we're just looking at where the absolute value of x squared is less than 1. In other words, we're effectively looking for where negative 1 is less than x squared is less than 1. And the short of that is that it happens when negative 1 is less than x is less than 1. So this is our interval of convergence for the power series that we just found. I have one more example of this one that I kind of want to let you guys try out. It might be a step harder than this, but we'll see what you do with it. You may find that it's just the same. So this other one I have is here. So I'm giving the information slightly differently. Given that the integral of 6 over 1 minus 3x dx is negative 2 natural log of 1 minus 3x plus c, find a power series for this thing. So really, and if you don't want a hint, then pause the video now and try it on your own. If you do want a hint, then here it is. This thing is a rational expression. Find a power series for that thing and integrate it. That'll get you this, and then you're just one step away from that. So I'd recommend you try this one on your own. I'm going to go ahead and go through it now. So first I have to find a power series for 6 over 1 minus 3x. Seems to me that shouldn't be too bad, because we should already be able to tell that the first term is 6 and that the common ratio is 3x. So I can tell already that 6 over 1 minus 3x is going to be 6 plus 18x plus 3 times 18 is 54x squared plus, let's see here, I guess we need one more, 162x cubed plus dot dot dot. And so great, that's that, right? Now, I can effectively find, by taking the integral of both sides, I can find negative 2 natural log of 1 minus 3x is equal to, and just like I did before, I'm going to put the c first, so is equal to c plus 6x plus 9x squared plus, let's see, if we divide the 3 out of that, you're going to end up with, oops, sorry, that shouldn't be a 9, that should be a, oh no, that's right, I'm second guessing myself, 18x cubed. The next one there works out less nicely, that's 162 fourths x to the 4th, and so on. Here again, I'm going to want to find out what that value of c is, so think about the convenient value that you use here. I'm again going to use 0, because all these are going to get blown away. So when I plug in 0, I'll end up with negative 2 natural log of 1 minus 0, sorry, not plus, equals c plus a bunch of zeros. This left side is going to end up being negative 2 times the natural log of 1, which is 0. We're basically going to find out that c is 0. So that leaves me with the idea that negative 2 natural log of 1 minus 3x is equal to, sort of like we set up here, 6x plus 9x squared plus 18x cubed plus, and I can simplify this a little bit, this is 81 over 2x to the 4th, and so on. And then the final thing I need to do to find a power series for the natural log of 1 minus 3x is to just divide both sides by negative 2. So I'll end up with natural log 1 minus 3x equals negative 3x minus 9 halves x squared plus, oops, not plus, minus 9x cubed minus 81 over 4x to the 4th, again not plus, minus dot dot dot, and that's our answer. Isley's crying. I'm gonna go help. Hope that made sense, and I will see you guys in class tomorrow. Have a good one.